As the name implies, an anonymous method is a method that simply has no name. It is a block of code that is used in a delegate instead of associating the implementation of the delegate with an existing method. So rather than calling a method in the delegate, we can add a block of code that it executes instead. So in this example, I'm creating a delegate called myDelegate, returns an integer, takes two integers, and so then we see my delegate instance equals delegate, the signature of the parameters, int I and int j, and then the block of code is returning those two added together. So that would be an anonymous method in that block of code. And so therefore we don't have to write methods in order to use them in the delegates, and it reduces the amount of code we write. So I'm going to take that encryption and decryption method that we looked at previously, and let's rewrite that using anonymous methods. So I have a delegate called secret encoder ring. It's referencing a string, so passing by reference XYZ, and then I've got an implementation of that secret encoder ring as encoder, and my delegate is again passing as the reference string, and then my body of code. I'm reversing the string, and where previously we subtracted 3 values from the ASCII value of each character, I'm going to subtract 5 this time. And then set ABC, the string that I passed, as a reference to reversed. Then I do another one. This one I call decoder. It's basically the same thing, except rather than subtracting 5 from the ASCII value, I'm adding 5. And that will turn it back to the original value of the string. Here's the implementation of that, where we're calling those. So I have my string, again, South Mountain. We have encoder, and I'm referencing that string. I'm going to show the value that's a result of that. Then I'm going to access decoder, and again, show the value of that back to the original string of South Mountain. Let's give that a try. So campus encrypted is now, and we get the string there. And again, you can see the capital N at the end here. So this is the capital S that was at the beginning since we reversed the string. Click OK, and now I'm decoding that string back to South Mountain. Most programmers use an anonymous method known as a Lambda expression. It's simply another way of writing an anonymous method. It's a little bit shorter and more common in the industry. It uses the lambda operator, which is an equal sign and a greater sign, and that's also pronounced as the goes to operator. On the left side of that operator are the input parameters, and on the right side then is the block of code that we want to implement. Here's our previous example of anonymous method. I've got a delegate that returns an integer I've called lambda delegate, and it takes two integers, I and j. Then I'm creating an instance of that lambda delegate called anonymous product. I'm going to take the delegate of integers a and b and return a times b. Now, that's not using a lambda expression. That's the way we learn to write an anonymous method. Let's look at how we write that then in a shorter way using a lambda expression. And so here we have lambda delegate, lambda product equals, and then notice my signature here is just the a and b as far as integers, because we've already defined in creating our delegate that I and j are integer values, and a corresponds to I and b corresponds to j. Then we have our goes to operator, our lambda expression operator. What is the implementation body of that lambda expression? And it simply is a times b. That's what's going to be returned as the integer based on our declaration of the lambda delegate. A lot less code. We don't need to specify a return because by default the lambda delegate that we set up is returning an integer, and the compiler understands that. We can also use a group of statements in the body of that lambda expression. So here I have lambda message as my delegate. It's taking 3 integers, I, j, and k, returning nothing. But writing that as a lambda expression then, we're going to implement it with the name of my message equals, there's our parameters, x, y, and z, and then goes to the lambda operator. And then my body is in brackets like we normally would in a method. And I'm having to do several things. So I'm creating a prompt, I'm creating a title, and showing a message box. Let's create an example of this. Here I have a delegate that's returning an integer called lambda delegate. It's taking I and j. I'm going to create the method of anonymous product as an anonymous method, and then create another one that uses the lambda expression, and another lambda expression named lambda message, taking 3 variables, I, j, and k, and then creating an instance of that called my message, taking X, Y, and Z. Those are going to be integers based on our delegate definition for Lambda message. And again, we're going to create a prompt, a title, and show a message box. So here's my button, BTN Lambda demo. That's this button down here in the bottom left. We're going to have integers of X and Y. We're going to get the product of those as Z, calling the Lambda products Lambda expression, and then use the second Lambda expression of my message and passing it again X, Y, and Z. Let's watch this run. And I'm told the product of 5 and 8 is 40. So it's taking 5 and 8. It's using the Lambda products Lambda expression to find the value of Z, and then using the my message to display the message box. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.